Okay, so what different gradients have we found for these lines that we've got here? Let's start off with Mabel. What have you got for the gradient of this downward sloping line? Pardon? -2. So this gradient here is -2. And what about its perpendicular line? A half. Arisa, what about this sloping one up here? Good. And what about its perpendicular? Okay, so what's the point that I'm trying to illustrate here? Shahan? Good. The perpendicular lines, they have a negative reciprocal of the other one. I think the easiest way of seeing this, actually they are each other's negative reciprocal. If you took the reciprocal of 1/3 and you change it from negative to positive, you get 3. Also, if you take the reciprocal of 3 and make it negative, you get -1/3, and it works for the other one as well. So negative reciprocal is a way of checking if two things are perpendicular. So with perpendicular lines, I've got a couple of things that I've written in your notes for you on the next page. It says the gradient of parallel lines are equal. Pretty obvious. If they're parallel, they have the same slope. But if two lines are perpendicular, then the gradient of one is the negative reciprocal of the other. The way that we might write this is m with a small 1 is referring to one of the gradients is equal to -1 over the other gradient. But if you wanted to show that two lines are perpendicular, you could multiply their gradients together and show that it's equal to -1. Why do you, when you multiply their gradients together, would you get -1 if they're perpendicular? To me. Yeah, good. When you multiply two things that are reciprocals, you get 1, and because it's a negative, you get a negative. You can also see, if you rearrange this formula where you have m1 equals -1 over m2, if you multiply both sides by m2, you get m1, m2 equals -1. So that's something that's maybe potentially new for some of you guys. So we're going to really quickly go through these ones. I'm just going to pick people to tell me what the gradient of the perpendicular line is. So Kausa, if the gradient is 2, its perpendicular is? Good. Locke, if it's -3, its perpendicular would be? Good. Saeed, what about if it was a quarter? I'll come back to you. You can do 5 for me, okay? So have a think. That one is going to be -1/5. This one will be, okay? Red one, what would this one be? A quarter. Good, -4. You take the reciprocal and, oh, it should say -4 there. My mistake. 5, what did we say 5 was? -1/5. Take it and reciprocal and make it negative. -2/7. Sharmin, what would be the perpendicular for that? Good, it would just be 7/2. Annarisa, 7/5? -5/7. Okay, so pretty straightforward for what our perpendicular gradients should be. Notice how if you multiplied any of these pairs together, the answer that you should get is -1. Okay, because they're all perpendicular, you should get -1. So we're going to just do 3 questions here that I'm going to do, and then you're going to try a couple of them, and then we'll do a little bit of practice on these and perhaps a little bit more as homework. So a line goes through the point 9, 10 and is perpendicular to another line with equation y equals 3x plus 2. What is the equation of the line? So remember, to find the equation of a line, we need a point and a gradient. We've already been given the point, but we haven't been given its gradient. But we have been told that it's perpendicular to this line. So what's the gradient of this line? Good, so we can say that this one's gradient is 3, so the perpendicular, m, would be -1/3, so we can just say it's y minus y1 equals m brackets x minus x1. Done. It's very likely when you look in the answers in the back of our booklet or when you look on Solution Bank that will have been rearranged. But remember, if the exam doesn't tell you it needs to be rearranged, you can save yourself 30 seconds, save yourself a little bit of time. But it's nice to be in the habit of doing it. So, second one that we've got here, a line goes through the points A and B A second line, L2, is perpendicular to L1 and passes through the point B. Where does L2 cross the x-axis? Ooh, so there's actually quite a lot of information packed into just 2 lines of working out here. Rather than trying to work out where L2 crosses the x-axis, what do you think we actually should do before we try and work out where it crosses the x-axis? We want to find the equation of the line. Before we can find the equation of the line, we need to find its gradient. Before we can find its gradient, we need to find the gradient of AB in order to be able to find its negative reciprocal. So there's many different stages packed into just 2 lines of working out here. So let's start from the beginning. The gradient of L1 will be the change in y, so minus 1 minus 3 over the change in x, which is 3 minus 1. So that's minus 4 over 2, which is minus 2. What does that mean that the gradient of L2 is? A half. Good. Take the reciprocal and make it switch from being a negative to a positive. So our equation of L2, which I'm going to just do L2 here and then I'm going to start working it out. Remember, our formula is going to be y minus y1 equals m brackets x minus x1. So we know that the m is a half, but what point is it going through? Which point does it pass through for line 2? Pardon? B. It passes through B. A second line L2 is perpendicular to L1 and it passes through the point B. So the point B is 3 minus 1. So for L2, I'm going to use these 2 pieces of information here. It's just going to be y minus y1, which is y plus 1, equals m brackets x minus x1. So we've now come up with its equation of the line. I'm not going to bother doing anything to that line. I've now got down to this part of the question, basically, haven't I? The last thing says, where does this line cross the x-axis? When something crosses the x-axis, what's true? Y is 0. So we can now get rid of this. So we now have that our equation is, when y equals 0, we get 0, we just get 1 equals a half x minus 3. Best way of solving the equation? We've got 2 options, either expand the brackets or times it by 2. It's probably the best thing to do. So let's double that side and we get x minus 3 and then add 3, so x equals 5. Where does it cross the x-axis? It crosses at 5, 0. I like that question because there's many things packed into it. The wrong thing to do would be to go and try and work on the end of the question. Often you have to think, okay, well if I want that, I want that. If I want that, I need that. If I need that, then I need that. And you just work backwards throughout the whole thing. Last one's pretty simple. Are the following lines parallel, perpendicular, or neither? So the top one is in, do you remember what we called this form when it was like the y equals mx plus c? It had a different name that we called it. The GCSE form, yeah. The slope intercept form. The second one, what form would we say this is? The standard form. So we've got a mixture of lines here. Which form is better to help us find the gradient? The y equals mx plus c, the slope intercept. So we can see for this one that m1, I'm going to call it its gradient m1, is a half. This one requires some rearranging, so I'm going to put the y onto the other side. So I get 2x plus 4 equals y. So its gradient is 2. Our m1 multiplied by m2 is a half times 2, which is 1. So it is not perpendicular. And we can also say m1 does not equal m2, so they are not parallel. So it is, so neither. Okay? You have got 2 questions on the next page that I'd like you to have a go at. You can just do those on paper for me.